All right, you guys, welcome back to another episode of Knowledge Drop. This week, dropping some knowledge on your heads. And, oh my gosh,
That's a new one.
one day the intro thing will be just a natural flowing thing, but not today. Anyway, thanks for coming back. Today, Derek's going to be teaching us. Derek, what are you going to be teaching us about?
So I'm actually wrapping up an internship, and I kind of want to share what I did and how it went, and kind of what I was doing, that kind of stuff. Kind of letting people know about it.
Like a real world engineering experience.
Absolutely.
Dropping some knowledge. Sweet. So before we get into it, let me hit you with a fun fact. If you're ever wondering, you're out in Arizona or New Mexico or California, you see that beautiful orange, purplish sunset. Have you ever thought what it's like on Mars? So the sunsets on Mars are actually blue. And when you see it, because you should Google it because it's freaking awesome. The rover sent back images, so we can actually see what the sunset looks like on Mars. But it looks amazing. It's straight up blue, and
So it's the same like kind of sunset as ours, just blue. That's it.
yeah, like how do I describe it? Blue.
A good description. Yeah.
Yeah,
Very
like
descriptive.
it's almost like a blue fog looking like haze all around. Because there's so many particles in the air on Mars, and because of those particles, they allow blue light rays enter the atmosphere easier than any other color. So when the light of the sun hits those particles, yeah, it just makes the whole atmosphere look blue.
That's pretty cool.
Um,
That is
I
pretty
wonder,
fun to learn.
what color is the sky on Mars? Do you know?
Um,
Jamie, look that up. Sorry, wrong podcast. What color is the sky on Mars?
I'm just gonna assume that it's kind of red.
Yeah, I mean the red planet, right?
Well, it's just the dust particles there is gonna be so like fine that they're gonna be blowing all over, and they're gonna be up in the atmosphere, and it's just gonna be kind of reddish all the time.
Well, it's actually kind of more of a pinkish red. It's
Oh,
not super
did you look
red.
it up?
Yeah, I'm that fast with Google. So it's like a pinkish red, but then yeah, like I said, with the sunset, sunrise, it's a blue. Um, it's kind of gray to me as well. So some people are saying it's a yellow brown butterscotch sometimes.
Oh, okay, that makes
Lovely.
sense.
Make you hungry.
Yeah.
Yeah, so that's cool. Now you know. That's what fun facts are all about. Something that you just say, you know what? I didn't know that. And now I do.
Yeah. Well, moving on to my internship.
Back to Earth.
Yeah. And just so we're clear, this isn't like me bragging or anything like that. This is,
Come
an
on. Yes, it
honest, I
is.
mean,
You know.
it is really cool. Like, I do want to flex a little bit that like I got to work on freaking rockets for the past 8 months.
Can you
But
say that you're a rocket scientist? I think you should. I think you
well,
should say that.
it's more rocket engineer, because like the science of rockets is not crazy. It's,
That's
can we
almost a little
build
bit.
something to take advantage of rockets the most efficiently? You know what I mean?
Yeah. But rocket engineer, I think that's like, that sounds higher than scientist to me. That's like, no, I'm not just theorizing about this. Like, I was there, I was hands on.
Yeah, yeah.
That's cool. All right.
So it was at Northrop Grumman. You guys might have heard of them. They're a pretty big
Formerly.
company. They make a lot of missiles for the United States to protect us and to do all kinds of stuff. I was specifically assigned to a project called Omega, and it's a new rocket that they were developing. And what's funny is we were competing, or I shouldn't say we have been, but Northrop's been competing for a contract to compete with United Launch Alliance and SpaceX, two other companies that build rockets, as you might have heard before.
Yes.
Um, and so, yeah, that's kind of what I've been working on. And there's going to be a few different little things that I'll talk about that I worked on.
Yeah, I want
Um,
to hear kind of what was your day to day like for people that want to know
yeah.
what actual engineering internships are like, or what do engineers do, what do interns do, kind of what's going on there. What's your day to day?
Well, so we should also, I'll talk about before the virus and after the virus because my day to day changed significantly.
It's like
Um,
a timeline dividing event right
yeah,
now.
seriously,
Like,
seriously. And so before the virus, when I was first just hired, I was super nervous. I was always like, they're going to find out that I don't know anything and they're just going to send me home. And so it was just kind of every day, every minute was just like all right, let's get busy and kind of do as much as we
Look.
possibly can so that they keep me around.
Yep, just be a quick learner. I think that's the best trait you can have.
Yeah. And
Like,
well, the other
fake
thing
it till you make
too,
it.
well, no, that's exactly it. It's fake it till you make it. I think one of the things that freaked me out the most was Northrop Grumman. I don't know if this is at other companies. I can only assume, but day one, they're like, okay, here's your workstation. Kind of get familiar with it, and we're all in cubicles, which is
Uh-huh.
crazy that I get my own cubicle. Is like, hey, you're a sophomore in school and you just showed up today, and they're like, okay, here's your cubicle. Here are your tasks. XYZ, and a lot of these tasks are things that they would have engineers be doing, but they don't like have time or they don't want to. It just takes too much time,
Right.
and so they pass it to the interns and they're just kind of like, all right, figure it out.
Good luck. Hope you paid attention in class.
Yeah. What's funny is a lot of my coworkers that have graduated, you'll go into their cubicles and they'll have like all of their textbooks like on the shelf.
Yeah, not a bad idea.
And so yeah,
They're there for.
it's very interesting to walk into a situation where you're expected to just kind of know and understand all of these really complex things, and if you don't understand them, they're like, either go ask somebody or kind of learn about it until you do start to figure it out.
That's cool. Just drop you right in. I mean, honestly, I feel like if you grabbed a person of average intelligence, and I mean a person who has interest, obviously, not just whatever, but somebody with average intelligence that's like, yeah, I want to learn, and you give them enough time. I mean, obviously you're going to learn faster than just whatever other person, but you know what I mean? Like, experience
Yeah,
is the best teacher. If you just actually get there and they say, this is the way we do things, this is our way, because they're going to do that anyway, no matter
yeah.
what your
Well,
degree
if you
is.
think about it, that's how learning has really evolved.
Hmm.
Like way back when like teacher and student relationships were first forming, it was, this is what I've learned and I want you to go do this thing so that you can learn from it as well and maybe learn something new.
You became somebody's apprentice, right?
Yeah,
Like,
yeah. And so
you are with the blacksmith every day blacksmithing, and so guess what, you get it. Like, you don't have to understand all the textbook details, but
yeah. And unfortunately today it's just kind of, they want you to have more of a foundation before you go into any one job, which is why they
sure.
require math and science and stuff, because they feel like that's gonna,
Well, when you're
for most jobs anyway, you don't really need to know the, I don't know, I can't think of
there's
anything
some
right
things
now.
there's some things that it's justified for. I mean, if you're going to be building a bridge, yeah, I want you to understand some pretty solid things, like concepts should be pretty solid in your mind because
Yeah, you should be able to balance forces and understand like the mechanics of the material that you're using for the bridge so that you're not making it out of mud and straw. You know what I mean?
yeah, the big bad wolf, he'll come in and just he will
Dang
wreck
it.
that.
I
He
walked right
will
into that
wreck
one.
that. Well, what I was thinking too is that what human being on earth can, or how many human beings, I guess, because maybe there are some, how many people can design and build a bridge themselves? Just that person. What I mean is that everything within engineering is a team. It's all a team. You're going to
Hmm.
need a lot of people. You're going to need people to check your work, and because you want to be sure. Like, if you're not sure, you could blow something up. You could hurt
Yeah.
somebody. You could kill somebody.
I remember in one of the classes that we took, one of the first things that was in the textbook was like the amount of man hours that went into designing and manufacturing the Boeing 747.
Uh,
If one person was going to do all of that work himself, it would take like 8,000 years.
right.
And
That's,
so
that's right.
they were kind of pushing the whole what you're saying is that like it's a group effort, and the weakness of any one person is the weakness of the group, and we help
Hmm.
each other and move forward.
Yeah, you don't have to know everything, I guess. You know, there's
Hmm.
some people that are like that who are just natural born geniuses. Um, I'm not one, but I think that even if you can just be, I don't know, like maybe your skill is making the team work. Like you're not the expert in the deep calculus that's going to go into something, but you contribute in other ways, even as
Yeah.
an intern.
Yep. And so getting used to all that was a lot of fun. And so kind of some details about Omega Rocket before I talk about like my day to day. So Omega Rocket, it's this huge rocket, and there's lots of different configurations. There's a like a light, medium, heavy kind of idea. And also feel free to ask any questions when they
Well,
come up.
okay, so got one.
Oh, okay.
When you say light, medium, heavy, is that like three different versions of it?
Um,
Or
so I think um, yeah. So for the light configuration, instead of there being six, there are six mini rockets attached to a main huge rocket.
okay.
And so for the light configuration, it's not what it's called at the company, but that's just kind of what I'm calling it.
Hmm.
There are only two side rockets.
Okay.
And then for the light to heavy, for heavy, the nose cone, like the big top of it, is called the fairing. The fairing is huge, and they have six um, rockets on the side, but then the middle of the rocket, the bigger portion, the huge part, is longer. And so
Okay.
they kind of play with all these different configurations for size and of existing products that Northrop already has.
So are they trying to find the ideal one? Is that what we're going for? Is that they're trying to find the
Um,
porridge that's not too hot, it's not too cold?
it's kind of like that because different payloads are going to require different
Okay.
capabilities.
So they might say this payload we need the light, this payload we need a medium or a heavy,
Uh,
that kind of thing.
kind of, because it's more like we need to put this very heavy payload to Mars, and
Right.
so they're gonna need the ultra big rocket. Or it could be, hey, we need to put this really heavy satellite into low Earth orbit. We might only need the medium sized rocket because it's
Uh-huh.
cheaper to make and it's more efficient to have the medium sized rocket than to make this overpowered rocket. Does that make sense?
Okay. Yeah, I gotcha. It's kind of like you don't want to waste too many resources you need to find the right version or configuration, like you were saying, for a certain payload, certain thing that you're taking. You need to have the right use of resources.
Yes. Yep. And you always want it to be the most efficient system possible, and that's kind of what they're going for by offering various payload capabilities with these rocket
Cool.
configurations. And so something special about the company portion of Northrop here in Arizona is it used to be called Orbital ATK, and they specialized in solid rocket motors and solid rockets. And because they focused on that and we have all of that technology worked out, a lot of Omega is solid rockets. There's very little liquid fuel.
Hmm. So very little liquid fuel. What does that mean? What are we using instead?
So there are lots of different compounds that you can use. So like the model rockets that we lit for our engineering class, that
Yeah.
was a solid rocket booster.
Okay.
And so imagine that, but the size of a, a building, like a giant tall building of just full
Right.
of solid rocket motor
Right.
powder. And then at the very, very top, where the fairing is, the nose cone, that's where they have a small liquid um, engine.
Okay.
And so the reason why they wanted to do a lot of the solid fuel is because it's a lot cheaper and a lot safer. Um, a lot of there's pros and cons to every choice you make, and with solid rocket motors, they're very stable. They're easy to produce. They're easy to control. Um, they have a really good. They're very reliable. That's what I was trying to think of.
Okay.
But you can't throttle them. Like you can't say, "I we need to go slower." Once you light that candle, it's going.
It's just burning.
Yeah. And
Basically
so,
like a controlled explosion almost.
yeah, absolutely. And so that's the con is you can't control it. You can't really once it's lit, that kind of thing. And that's why there's not a lot of solid rocket motors being used, just because people want the flexibility. Like SpaceX, they use liquid because they can control exactly how much thrust and how many engines are lit, and it gives them a lot of flexibility for what they want to do. But with
Sure.
Northrop, it's just like, hey, we need to get this thing straight up into space and not worry about
It's going up there anyway. Just light it.
it. Yeah. And the other cool
What do you
thing
need
is
to stop for? Just keep going.
if you look at a video of one of Northrop's launches for Antares, that's their other rocket program. It when it gets lit, it goes fast, like right off of the pad. You can see it moving quickly. Whereas if you look at the like SpaceX launches or the United Launch Alliance launches, it
Hmm.
takes them a second to like they light and then they kind of and
Yeah,
then they
it
start moving
always
up.
I think all the launches that I've seen, or the ones that you see movies, TV, it's always like this slow, like boom, like it's lifting
Mm-hmm.
slowly, it's heavy. But you're saying that one's just kind of quicker, like takes off.
Well, if you think about it, once you light a solid rocket booster, all of the fuel is burning that it possibly can all at once. It doesn't have to
True.
move through any
Yeah.
compressors or any kind of turbo fan or whatever it is. It's lit and it's gonna immediately burn all the fuel it possibly can until there's none left.
Boom. Cool.
Um, and what's funny is Northrop. So Orbital ATK um, built the solid rocket boosters for the space shuttle. So if you look at the space shuttle, the two white rockets that are attached to the whole thing, those are the rockets that Orbital, now Northrop, built. So it was
Cool.
kind of cool to have a connection to that.
Sweet.
Um, and so a few of the projects that I was working on, I can't really go into all of them because there's a bunch of them, but some of the ones that I thought were kind of cool. I was asked to come up with it's called a bill of materials, and so you
Yep.
write. It was an Excel spreadsheet, so you just kind of you make a giant list of, okay, here's the rocket engine. What do you need? Everything that attaches to the rocket engine. What's the next lower step of all the components? And so like, oh, we have rocket engine, then we have bracket. What are all the things that go into the bracket? We have X, Y, Z, and then all the fasteners and washers and stuff like that.
Uh-huh.
And this took me, they wanted me to do this for um, a few different parts of the rocket, and it was a mile long. It was such a long list, but it was a lot of fun because I was able to like open up the entire rocket on CAD and look at it on my computer and
Yeah,
just kind of get familiar with it.
you're breaking it down and, you know,
Mm-hmm.
getting down to the nitty-gritty.
Yep.
Hey,
So
give me
like,
a second.
yeah.
Gotta get these keys to my in-lock.
Okay, now we're back.
Back in business. So
Yeah.
you're breaking down the bill of materials.
Yeah. And so it was just kind of fun to be able to look at all the different things that go into engineering, because you would not think it would need all of the little things that it needs. Like we always say, like, oh, there's a computer that runs the rocket, but you never
Yeah.
think like how many computers there are. Like there were probably like 20 or 30 different computers throughout the entire rocket. It was insane. And
Jeez.
the amount of wiring that I saw was just, it was bonkers.
Is it like miles and miles of wire?
Oh yeah, easily.
Jeez.
Um, and so one of the other things that I was able to work on was they made so at the very, very bottom of the rocket, um, where the rocket cone is, that like where the thrust comes out, the flamey end.
The fiery. Yeah.
Yeah, that's what everyday astronaut calls it, the flamey end. Um, the flamey end, they have this thing called the aft skirt, and they built a mock-up of the aft skirt at Northrop in Phoenix, where I worked. And my job was someone had already 3D printed all of the components, like mock components, like computers and hot gas generator, thruster stuff, and crazy things.
Uh-huh.
They'd already 3D printed all those components, and then they took rope and they wrapped tape around the rope so that it could mimic the bending of a wire and of a cable. And then they plugged, quote unquote plugged, it wasn't real plugs, but they put all these cables where they needed to go.
Hmm.
And one of my jobs was, because they were just plugging everything where it needed to go, they didn't think about organization at all.
Oh.
And so it was just this crazy like rat's nest of cabling and wires everywhere.
So were
And
you in charge of kind of organizing that
yeah,
mess?
and so what I spent a few weeks, like the first couple days I just spent like staring at all of the mess and was like trying to like figure out where stuff came from and where it was supposed to go. And eventually I like started moving all these components, or not components, all these cables around. And they have these cable tie bases, which if you've listened to our podcast, cable tie bases are also zip tie bases, just so we're clear.
Don't come at me with that zip tie stuff. They're cable ties.
Yeah, yeah. So
No,
they
just kidding.
they have these cable tie bases that they're like, all right, you're organizing all the cabling in this section of the rocket. Where you decide the cable ties are going, that's where they're going to be on the rocket. And you're going to have to tell the technician in a instruction manual where to put all of these cable ties and all that stuff.
I can just imagine right now, like, uh, what caused the explosion of the rocket? They seem to trace it back to the wiring.
Yeah.
Oh,
Somehow the
who's in charge
wiring
of
got
that?
sucked up into the thrust and ripped out all the computers, and it didn't know where to go.
Oh man, Who was that guy?
Yeah, but it was cool. I wish I could show pictures of it, because the before and after just it gives you that like, oh yeah, that's good, that's good. That looks
Yep.
nice. The OCD is satisfied. So that was a lot of fun. Plus, like when you're inside of this mock-up of the aft skirt, like it's huge, and you get to like walk around and you see like the labeling on this. It says like um, hot gas generator. I mentioned that before. It's like something that helps separate the rocket, and yeah, it's cool. It was fun to
So
being
you
able
get
to
to
do that.
walk inside a live, what? Not live, a a realistic model of the rocket, so you can
Yeah.
see what's going on.
Yep. They got some. They had paid someone to fabricate this section of the rocket with sheet metal, and then we went and drilled holes in it and put all these 3D printed mock components in it. So it was as accurate as it could possibly be without like live ordnance in the rocket. Does that make sense?
So yeah, so is that where you organized all your wires and did your stuff, or was it on the computer, or how? Where was it?
So it's actually really hard to model cables in the computer. At least
Yeah, I
I
bet.
found it was. And so in the computer, they kind of have like a rough estimate of where the cables are gonna start and end, and like kind of the route that they're gonna take. And
Yeah.
so that's how the guys who made the cables, they made them a certain length, and they were able to wrap them with tape to make them a certain thickness, because the cable in the model is a certain thickness with, so it like maybe that has 10 wires in it or maybe two. And so they kind of have to wrap tape around it so it bends like 2 wires or it bends like 10 wires. Does that make sense?
It does make sense, but I don't think you answered my question. Was it
So
on the computer then?
so the computer had cabling in it, but they didn't know the actual dimensions of the cables. Like they had rough estimates in the computer. And so when
So
I
that's why
went,
you had to have it in person.
yes, when I
Okay.
had to went to the mock-up, I had to be like, "Oh, guys, this cable is like 4 inches short because I had to
Yeah.
take this path."
Sure, sure.
And so
You
it
had
was
to
kind
you
of
had to
fun.
make it real.
Yeah. And unfortunately, um, right after I was working, like kind of right in the middle of me, not in the middle, towards the end, is when Northrop sent everyone home because of the virus.
Mm-hmm.
And so, sadly, my internship is over next week,
Wah, wah.
and so someone else is gonna pick that up and finish it. The other cool thing that I was able to build, so on the very top of the rocket, where the fairing is, when that fairing is in space, it needs to be able to orient itself to like be in orbit or maybe spin a certain way so it's stable. You know what I mean?
Uh-huh.
And so they're called roll control thrusters, um, reaction control system. Sorry, RCS. And we needed to build a mock-up of this whole thruster system with 3D printed parts and like PVC pipe and plywood and stuff, because there was a part that you needed to be able to reach once the rocket was fully assembled. You only had like a small window, like 15 by 12 inches, that you had to reach through your whole arm span with a wrench and unscrew this big old thing, take it out, and then put another part in and screw it back on. And so it was kind of fun to like use their machine shop, because the job I had previous to that was a machine shop kind of job, and so it was kind of fun to go into aerospace machine shops, which are crazy cool.
Yeah. Putting that knowledge to use.
Oh yeah. Um, and so yeah, unfortunately, now I don't know if any of that work is useful because Omega didn't win the contract between ULA and SpaceX.
Hey man,
It was still fun and I learned a ton,
you
but
lost to the best. I'm
yeah.
just gonna say it.
Yeah.
I'm just kidding. No, that's too bad, but I mean, it serves you.
Oh yeah.
Like,
Oh yeah.
it serves you for a lot because you got the experience, and now you can say that you worked on the Omega, you know?
Yeah,
That's
and
awesome.
I'm also, because I have a 3D printer and I was bored during quarantine, I've been building I think it's 1/100th scale of Omega. And so
Yeah.
like I actually have it with me. These are the side boosters I'm showing to the visual YouTube watchers. But it's just this little 3D printed rocket. It's like as long as my hand and as skinny as one of my fingers, so it's not too crazy. But yeah, I've been sanding and painting all week trying to finish it before my internship ends so I can show it off to all my bosses.
Cool. Yeah, that's cool.
And then, so those are all my Omega tasks. Something that was unique to my internship was I was asked to help another program at Northrop. And this program, it is unclassified, so I'm allowed to talk about it. It falls into, so the name of the program is called Supersonic Sea Skimming Target, triple ST for short.
SSSS. Oh, okay.
Triple
I
ST
was
for short.
all right. I was throwing in too many S's.
Yeah. So what this program is, so the Navy, they need to practice shooting down fighter jets. And so what
Uh-huh.
this program does is they build little tiny missiles that are like, I don't know, as long as your car and probably only about as wide as like a basketball, maybe a little bit wider. But
Mm-hmm.
they build these vehicles and they make them as maneuverable and as fast as potential enemy fighter jets, and then they fly them so that the Navy can practice shooting them down.
Really advanced clay pigeons.
Absolutely, and it sounds way more fun.
RACP. Working on that
um,
RACP.
yeah, so that was a lot of fun. I didn't actually get to work on the vehicle itself, but hopefully next summer. I did make some good impressions, and hopefully next summer I'll be able to go work on it now that Omega is done.
At the very least, somebody who has experience is better than somebody who doesn't. So
Yes.
you're already ahead of a lot
Um,
of people.
yeah. And so the thing that I did do for them is they have a special toolbox that has specialty tools to work on this vehicle. And
Hmm.
so it was my job to kind of use um, like Home Depot available materials and build a crate that can fit inside of a shipping container that can be easily removed and manipulated so they can get the toolbox out and use it.
Cool. You
Um,
contributed.
yeah, there is a official document at Northrop that has my name on it as the responsible engineer, the RE.
Oh man,
Yeah, so it's a big deal.
you're screwed now. That's
um,
cool, man. That means you're official.
that's how I saw it.
Yeah. Heck yeah.
Yeah. And so to kind of, from looking back on my internship, the day to day was very hard because all aerospace companies, they work a 980 schedule, so like you work 9-hour days, but every other Friday you have off. So
Hmm.
I hadn't worked a 9-hour shift in my entire life, so that was like super hard. And I was like getting super addicted to Dr. Pepper at like 2 or 3 o'clock in the afternoon.
Yep.
And
You gotta
so
be fun.
but that was before the virus. After the virus, I took my desktop computer home, and because of childcare and stuff like that, I have to like kind of work in the mornings and on naps and a lot at night. And so it's kind of
Sure.
like it's really nice and it's really flexible, which was a super like huge blessing. Um, but now that I've kind of lived through all that and I have all these experiences, we could call them. Um, some things that I learned that I want to talk more about is the fact that like I I have a hard time that like if especially in class if someone says something and I don't understand it and they move on, I get lost. And so
Hey man, you're not alone.
Well, and it's just like if we were in a meeting and someone was giving instructions and they were like, we need you to, they kept saying the word ECS, ECS, ECS. And I was like, oh man, I don't know what this is. And I don't know what they're talking about. And I don't know what context or what questions to ask. And I made it a point, from that time going forward in my entire internship, that when anybody ever said an acronym or ever said anything that I didn't understand, I was like, wait, what does that mean?
You got it. Yeah, you got to ask immediately.
Yeah.
Because if you don't, you let it go, then
It just gets
a
awkward.
year later they'll still be saying ECS, and you'll be like, "Hey, man, what does that mean?" And they're gonna be like, "You don't know what that means?
You're like, you've been
Been
here
here for
this
so long."
long?
Yeah,
Yeah.
then it's more embarrassing.
And just so we all know, so that you don't have to ask, ECS is Environmental Control System.
Oh, it was driving me crazy. Environmental control. Okay.
And what's
Yeah.
funny is, like, even though they seem like dumb questions, like, what does that mean? Or can you explain why that structure doesn't fall down or whatever? I felt like they respected me more for asking and wanting to understand the problem in its entirety.
Yes, of course. I mean, people have it so backwards. I think that if you're the person teaching or you're the person explaining something and people are asking a lot of really what you think are obvious questions, then you need to realize that you're not teaching at a level that people are getting. Like you're teaching up here and they're down here. It doesn't matter what you think of how smart you are, but you're not being a good teacher. Like
Yeah. Well,
it's
if you think about it, it's stupid for you not to ask, because
yeah, it
you're
would
not
be
going to be able to do your job. You're not going to, yeah, I don't know. It
it's
was
a
it was an
dumber
interesting lesson.
decision, a much dumber decision to decide to remain ignorant. But unfortunately, as well, when it comes to professors, we don't really get a choice, like you were saying.
Yeah.
Like, especially if it's an auditorium sized class, you got 250 people. Yeah, I'm sorry, but you just won't get the opportunity. And that just kind of sucks as a student. Like, sorry, you gotta,
Yeah.
I guess what we have to do is just jot it down and look it up, find someone who could answer that question later. But
Yeah. I feel
sometimes
like
you're not
that's
fast enough, you're not ready, and you miss it, and that sucks because they're not teaching at our level sometimes.
hmm Well, and I also feel that, like, when you're in that position where you're at school, it's kind of like they're teaching us how to look those things up. If we don't know, we should know, and we need to know where to look. Does that make sense?
It does.
Because,
Yeah,
like, there were a
that
lot
is
of
part of it.
questions I had that I can't just Google,
Oh
you
yeah.
know?
Oh yeah. Yeah. And it does help you as well, a little bit with networking, because what I found, especially at my job now, is that when I go to somebody for help, they enjoy helping me, which
Yeah, everyone
is
likes to feel needed.
yeah, it's not something that I would have expected. Because you feel like you're annoying that person, or you feel like that person's gonna see you as ignorant, or they're gonna see you like, this guy doesn't know how to do anything. But it's not true. Like they understand you're new. They understand that you know, you just got here. So especially at the beginning, take advantage of that, man. I mean, ask all the freaking questions you can, because after you've been there for a year or more, yeah, then people are actually gonna see you like,
You should know how to do
yeah,
this.
like you should know this by now. Like
hmm
you've been here a while, so man, don't hold back. Like seriously, and people like the relationships that I've formed at work are from people that I've asked for help.
Oh
Like
yeah,
those are my friends now because they're the ones that are nice, and they like helping me because it makes them feel like they know stuff. Like when you feel like you're like, hey, that makes them realize, hey, I'm an expert in this. Like I get this. And that makes you feel good because somebody's coming to you for help. And so that feels good. So
yep.
Take advantage, man. All of you guys, wherever you
Life.
are, school, new job, whatever, take advantage of being new, because when you're not new anymore, that's when the hammer actually falls.
Well, and yeah, it also is just like good practice because if they need to downsize, who are they going to want to fire? The guy who just got there that is picking things up really quickly, or you that don't ask a lot of questions and have been there for 2 years and still don't know how to do X thing?
The guy they're going to get rid of is the guy that nobody's going to miss, that doesn't talk to anybody, and that just comes in and clocks out every day.
Mm-hmm.
I mean, and there's obviously a lot of aspects of like everybody's a number. Like if this guy can do 4 in the same time that this guy can do 2, you know, they're going to pick the guy that can do 4 usually.
Yeah.
But there's a lot of factors, you know. But it's every job that I've gotten has been from people that I know. And then from that job, those people knew people. And so now I got another job, a better job, because those people knew people in the same industry. You know what I
Mm-hmm.
mean?
Yeah. Yeah. All the jobs that I've ever gotten are same thing, is like I either knew someone or I met that person in person. Like for example, this Northrop internship, they had a job fair kind of thing. Not really job fair, but it was like a presentation of like, hey, we do this internship every twice a year, and we're starting the 7-month internship in January. And
Mm-hmm.
so I went to that meeting and I met the person who was going to be hiring me, and I made a point like, yeah, it's kind of nervous because like he's like one of the directors of the program for Northrop. And from the first time I got in there, I was like, I have to go shake his hand. I have to make a joke. And I want him to remember me
Yeah,
so that when he sees my resume, he'll be like, oh, he's that cool kid that, has all the jokes.
that's right. That's right.
Um,
Yeah, that's what you got to do.
yeah. And so when I switched from going in person and kind of going in every day and doing that 9-hour thing, when it switched to doing the at home stuff, I really started to learn about workflow and like what works for me, because when I was going into work, I was finding that like I would take every task that I could possibly get and I would just work myself so hard, and then I would get kind of burned out and I would just come home and just melt into the floor.
Yeah.
And when I was working from home, because everyone was adjusting to it, I had to like pace myself because
Sure.
everyone was trying to do online work and not all the tasks are suited best for online work. And so
That's
um,
true.
being able to pace yourself, like, yeah, you want to shine and you want to show people your abilities, but there's also a time where you need to draw a line and say like, hey, I need more time on this, or hey, um, I don't know how to do this and I'm still figuring it out, I need more time, or XYZ thing.
Yeah, I work uh I work 12-hour shifts now. So I work
Oof.
3 12-hour shifts during the week. Um and you need to watch yourself, because all of a sudden, and when you're working with certain tools, there's, and also the parts that I work with are very heavy. Some of them are like 350 pounds. So to get them into my workstation, I have to use a crane. And if you've
I didn't
been
know
there,
that.
yeah, if you've been there for 10 hours and you burn yourself out and you have tunnel vision, yeah, you can drop something on your foot, or you can
Yikes.
slice your hand open. Uh, there's a lot of things that can happen to you. So you'll see guys just chilling. I mean, honestly, just taking like 50, not 15 minutes, but because you have your plan breaks, but then just take your time, use the time
Mm-hmm.
that's given to you and just relax. Because if you kill yourself, then guess what? You can't work anymore because you're dead.
Yeah, good point.
So,
um and then kind of the last thing that I definitely learned from the internship to wrap things up is like the aerospace industry, definitely the place that I want to be.
It is cool.
And
Yep.
it's not only that like it's cool, but there's so many things that are happening in it, and it's just gonna explode going forward. And like I don't know if I'm gonna want to continue working for a company or start my own business in like 10-15 years to build robots on the moon or something. I don't know, something cool.
Yeah.
But this is the part of the workforce that I really enjoyed being a part of, and I I really enjoyed it. This is just kind of the bottom line.
Yeah, man. It's when something's your passion, makes it a lot easier. You
Yeah.
don't feel like you don't feel like you're dying when you go to work, you know?
And it's nice to like it's a job that I can, when I come home, I'm home. I don't have to worry about stuff. I can do my own thing and be with my family.
Yeah, that's right. That's what we all need. Separation. All
All
right,
right.
man.
So
That was
to kind
cool.
of wrap up, do you have any good recommendations? I'm excited about mine.
Oh man, go first.
So I know you guys have seen, if you haven't, I envy you. But if you haven't seen any videos by Mark Rober, you are in for a treat. Every one of his videos is a complete gem. And he does all kinds of cool science and engineering stuff. And the video that kind of came out that I saw was he was in a shark cage that he designed himself, and sharks started attacking him. Kind of cool, but scary. And he got to ride in a private jet because of coronavirus. And um, yeah, he's super cool guy. I I also, my wife, she really enjoys watching his videos, even though she's not super into the engineering stuff and science. She likes science, but she hadn't seen all of his videos. And so this weekend, we just kind of binged most of all of Mark Rober's videos.
They're so good.
Yeah. So yeah, I don't know why I haven't recommended him before, but probably because he's just so popular. But yeah, if you haven't heard of him, Mark Rober on YouTube.
Sweet. Yeah, I highly recommend Mark Rober. He really is a genius. Like he's a smart guy. Um, let's see. What was I gonna recommend? I had something. Oh, if you haven't seen The Umbrella Academy on Netflix, go watch it. It's fun.
Really, I've been hearing people saying it's good, but I haven't like gotten myself to watch it yet.
Yeah, I mean, it's like watching a comic book. So like crazy stuff happens. You just gotta recognize that going in. Like it's like watching Marvel, you know?
Gotcha.
It's just for fun, but it's really cool. It's really well done. It's a constant mind warp where you're like, what the heck is gonna happen next? So yeah, if you haven't seen Umbrella Academy, go watch it. It's really cool. Seasons 1 and 2. Season 2 just dropped. So that's my rec.
Well, awesome. Um, always feel free to reach out to us on social media. Keep an ear out because we're going to be doing a giveaway soon. NASA JPL, they launched the Perseverance rover last month, and they also released the CAD files for 3D printing a scale version of the Perseverance rover. And so I am currently 3D printing a Mars Perseverance rover to give away.
Sweet.
And so listen for details in the future about that.
All right, guys. Tune in next week and take it easy. Bye bye.